Okay, so when we talk about quantity changing, we are talking about the derivative because a rate is a derivative, right? Another word for rate is a slope, right? Change over time. Rise over run is slope, right? Well, the rise is the x over the y, or sorry, the other way, y over x, right? In this case, x is always going to be time, right? It's always going to be time. When related rates, x is always time. The x-axis is always time. Y is some sort of quantity, okay? So anytime we're dealing with these things, anytime we're finding derivatives, it's always going to be d something over dt. It's always going to be with respect to time because it's a rate, okay? Okay, so what do I mean by that? Well, we're going to convert some of these into rates. Okay, well, they already are rates, but we're going to convert them into notations. Okay, so example number 1, Marty is growing at a rate of 3 inches per year. 3 inches per year. So the quantity is inches, and then there's the time, right? So we're used to writing it like this: 3 inches per year, right? And that's correct. But what we're going to write it, anytime we see a rate, we're going to write it like this right here: d quantity over dt. Okay? So instead of writing like that, dt is always going to go on the bottom because it's with respect to time, right? Years is time. The top is the quantity. This one's inches, right? So we're going to write di for inches, but it's really inches. Di dt for inches. And that's equal to positive 3. It's equal to positive 3 because Marty is growing, right? He's growing. If he's getting taller, it's positive. He's growing positively, right? All right. My stock portfolio is losing 5 cents per day. Okay. So losing, right? So if it's losing, that means rate is falling, going down. So it's going to be minus 5 cents. Okay. Or I should write it not minus like that. I should write it as a decimal. All right. Okay. It's a rate. So it's going to be over dt. And then the top is the quantity. What is what per day? Cents, right? Cents per day. So you can put DC for cents. Or since we changed it to dollars, we wouldn't put cents like that. We would put dollars, or DD is okay. Something like that would represent what that is. Money is changing over time. How much is it changing? It's going down by 5 cents. Okay. The radius of a circle is getting larger by 4 feet each hour. Okay. So that's the rate, 4, right? It's getting larger, so it's going to be a positive 4, right? So the rate, we're going to write it as dt goes on the bottom. On top, what quantity is getting bigger? Not feet. That's not the quantity getting. That's how we're measuring the feet. There you go. So it would be dr, right? Wait, this one should be, change this one too. This one should be d portfolio, dp, dt. Yeah, it shouldn't be cents because that's already represented on the other side. Okay. The outside temperature is dropping by 5 degrees, right? So minus 5 degrees Fahrenheit per minute. dt goes over here. So what is dropping 5 degrees per minute? Temperature, right? Temperature, we usually use capital T for temperature. Lowercase t is usually time. Uppercase T is usually temperature. Okay? So you're going to see some rates there, and you're going to have to, it's going to say the rate of the radius of the circle is getting larger by 4 feet each hour, or 4 feet each minute, or whatever, 4 feet each day. So we have to, these are the ones you're mainly going to see stuff like this. Okay? So we have to figure out a way to label them. Okay? Okay, so the derivative. So we're going to take the derivative of each of these guys. So let's do A first. The derivative of each of these guys with respect to time. With respect to time. Because everything with related rates is with respect to time. So dt, d something over dt. Okay? So if I'm going to take the derivative of this guy right here, what's the first part going to be? What's this part going to be? The derivative of this part. Take a wild guess. 2a, yep, that's right, 2a. And since it's with respect to time, it needs one of these. It needs a tag, right? Same thing with 2b. It's with respect to time. And same thing with 2c. It's with respect to time. So I'm taking the derivative of each of these letters, A, B, and C, with respect to time. So that's why I have to have those little tags there. Okay? We didn't have to do it back when we were doing this. If I was finding derivative of this, we didn't have to do that, remember? I didn't have to do, because it would be dx over dx, right? And that's just 1. So that's why I didn't do it down there for these guys. But everything is with respect to time now, so it's got to be a dt. Okay. All right. Now this guy. So that a squared plus b squared equals c squared. That's Pythagorean theorem. You guys have seen it many, many, many times. We're going to be using that. We're going to be using that in this section. Okay. Some of the formulas we're going to use. Another formula we use a lot in this section is this formula, pi r squared. What is pi r squared? Area of a circle. Yep. Area of a circle. Okay. So I got to find derivative of this guy here with respect to time. So what's the derivative of A? Capital A. What's the derivative of A? Not 0. No. Just 1. And then what else? It needs a tag because it's with respect to time. So you can put a 1 over here if you want. You don't have to put a 1 because it's implied it's a 1. Okay. What am I going to do? I'm going to throw a trick question at you. What am I going to do to find the derivative of this? Remember, it's a trick question, so think about it before you answer. What am I going to do? No, I told you guys, it's a trick question. It's a trick question. I'm not going to use product rule here. Why not? I'm going to use just the regular old power rule, yeah. But why? Why is this one not a product rule? Because I know natural instinct is just to say, oh, product rule. And most of the time you're right. But for this one, why is it different? Why is it different? Yeah, Roman? Pi's a number. Yeah, pi's a number. So that number, it could be like 4. right? Pi is not 4, but pi is a value just like a number is, right? So if this was 4r squared, right? You would say, oh, multiply the 2 times the 4 and then go that way, right? Treat it the same way, yeah. Treat it the same way. So move the 2 to the front with the pi, so it's 2 pi r. And then what else needs to happen? dr dt, because I found anytime you find a derivative of a variable, you have to put a tag with it in this case, because everything is with respect to time. Everything is with respect to time, okay? Okay, we're gonna do one problem together. We'll do one problem together and then we'll be done. Okay, we'll finish the rest on Monday. Hopefully we'll have time to finish one problem. These are the steps we're gonna do. These are the steps we're gonna do. We're going to write down everything they tell us. Everything they give to us, we're going to write it down. Second thing we're going to do is we're going to write down everything we need to find. Not necessarily, so number 2, we don't know, but we need to find it. Number 3, we're going to write an equation that relates the variables. That's where the related rates comes in, relates the variables. Number 4, don't worry about that today. Number 4, we'll talk about later. Find the derivative. Number 5, plug it back in and solve. Okay? Okay. Just kind of talked about those. Let's see. A rectangle. It's always good to draw pictures because, like I told you guys the other day, anything you can make visual in calculus will help you. Okay? So it's always good to draw pictures anytime you're doing these things. Okay? So we have a rectangle. Has a length of 1 inch and a width of 6 inches. Okay? So usually length is side by side, right? And width is up and down like that, but it's kind of different, right? So the rectangle kind of looks like, let me draw a more accurate rectangle. So the rectangle is kind of looking like this, right? That's more what the rectangle looks like. Okay. So we have, this is 1. I'm not worried about units right now. I'll do units at the end. Okay. Units are important, but I'm not going to worry about that right now. I'm worrying about it at the end. And then what does it say? The width is 6 inches. Okay. The length is increasing. The length is increasing. This guy right here is getting wider by 4 inches per second. So every second, this guy is getting bigger and bigger and bigger, 4 inches every second. The width is getting bigger as well. It's getting bigger by 8 inches per second. So this bottom part right here is getting bigger, and this one is getting bigger too. So the rectangle is getting bigger. Okay, kind of zooming in, it's getting bigger. Okay. What is the rate of change of the area? So obviously, if the width and the length are getting bigger, the area is going to get bigger as well, right? Well, what rate is it getting bigger? That's what we need to figure out. Okay. All right. So now we got to list everything we know. Okay. So we're going to label this. So anything that goes side to side, I want you to start labeling with an X. So I'm going to call this side X. Anything that goes up and down, I want you to label with a Y. So this side's going to be Y. Okay. It's important because watch what I do later. So I'm going to label everything I have. I know X is 1. I know Y is 6. Right? The length is increasing by 4 inches per second. So how do I write that? How do I write that on my list? So I need to write it down here. What am I going to say for this guy right here? It equals 4, right? Because it's getting bigger. So something equals 4. What am I going to write here to identify it? The rate at which the length is increasing. The length is increasing at that rate. So what am I going to write here to show? Not dl, because I didn't use L. What did I use? X, right? So yeah, same idea, just dx dt. Dx dt. Okay? I got a little lag there, but it's dx dt. Okay? And then I also know, oops, totally got shut down. And then I also know that the width is getting bigger, right? So what am I going to label the width? Do that right now. Don't wait for me to write it down. You write it down right now. What is the width going to be? The width is getting bigger. While I get this thing to reappear. So what is the width? What am I going to write for the width? Perfect. Just like that. You should have that on your paper right now. Don't wait for me. You're not robots. You can do it on your own without watching me. Okay. And then what's the last thing? So that's everything I know, right? That's everything I know. What's the last thing I need? What's the last thing I need? Add one. No, because it's dx dt is just the rate. It has nothing to do with what it's already there. It's just the rate. Yeah. Yeah. So it's just the rate. So yeah. Okay. So what is dA dt? Or what is, why is this not working? Help me out here, guys. We got 8 minutes and we got to finish this problem. Help me out here. Don't just sit there and, yeah. No, we still haven't. Why is this not working? So what are the things that we know? Let's talk about that. What are the things that we know? Well, my computer's not working. Let's see. Let me just go straight to it. I'm not going to be able to see it, but because I can see some people are already losing focus. All right, put everything else away. Everything else away. Okay. So what do I have here? What's the next thing I have? dy over dt. You already should have this written down. It shouldn't be news to you. Okay? Don't wait for me to write it down. Okay, so now I can get back. And then what's the last one? What's the last thing that I put up there? Help me out. What equals 8? dy over dt? There we go. dy over dt equals 8. Good. So is that everything that I know? Okay. Step 2. What does step 2 say? Okay, what am I trying to find? Okay, so how do I write that? Okay. dA over dt. What does that equal to? You should already have this written down. What is it equal to? What is that equal to? What is that equal to? What did you say this was? What was step 2 said? What does step 2 say? What we're trying to find, right? So if it's what we're trying to find, what is it equal to? I don't know. That's where it goes there. Okay? We don't know. That's what we're trying to find. If we have that answer there, we're done with the problem, right? Mm-hmm. All right, go. Okay. All right. So now what we have to do is find that guy here. So we have to find an equation that relates all of this. So what is an equation that relates all of this stuff here? What is an equation that relates all of this stuff here? Think of an equation that relates all of this stuff. Yes, but yeah, I know what you're saying, but that relates to this stuff. There you go. Which is length times width, right? But if you say length times width, it doesn't relate all of stuff. The stuff that relates all of this is this guy right here, right? That's the guy that relates it, right? All right. Skip the next step because we said we don't have any of that. What's the step after that? Find the derivative. What's the derivative of this? No. We got to find the derivative of this guy first. Okay. So dA over dt equals, so we got x dy over dt plus y dx over dt. Last step, plug in and solve. dA dt, we got a big question mark here. What's x? Okay. What's dy dt? Okay. Plus, what's y? And what's dx dt? And solve. Question mark equals 8 plus 24, which is 32. 32. Don't leave it as 32. What did I say about units? Don't worry about them until the end. What units go with 32? That's what they're using, right? Inches per second, right? But it's area. It's area, right? So I can't put inches squared. What do I, or inches per second? What do I put? Inches squared. It has to be inches squared. Yep. Okay. That's essentially what we're doing here. That's essentially every problem we have will follow those steps there. Okay. All right. Okay. So we'll finish this on Monday. Yep. Don't lose this. Don't lose this because it's the same one we're going to be going over on Monday. I'm not going to give you anything else. Okay. And I don't have any extra copies. So make sure just put it somewhere safe. All right.